Obviously, the graph has an arrow here and an arrow here. It has an arrow here and an arrow here, right? So it's clear that this is the graph of the function we are looking at. I should have also asked, is this a function?
Yes.
By the, yes, it is a function. Good. When I look at the domain, I see that something happens here. So obviously it crosses at 2. Let me get another one. You don't have to do it back. I don't give all quiz grades anyway. So, but I need another one because I graphed over on top of it and it's way too thick. Okay, so obviously when I try to determine the domain, I see that if I draw vertical lines, and so this appears to be 1, right? Right in the middle between 0 and 2, correct? So as I said, approximate. I accept anything that you read. However, I hope you agree that this line, which is not part of the graph, is somewhere between, right in the middle between 0 and 2. Would you agree? So this appears to be at 1. Now, also, this line appears to be exactly y equals 2. Would you agree? So this is the line x equals 1, and this is the line y equals 2. Would you agree? Okay. So then the domain of this function is obviously everything except 1. So when I draw a line at 1, I don't hit the graph of the function. So then the domain will be negative infinity 1, union 1 infinity. Would you agree? Okay, part number 2, range. So in the same one. So if I draw horizontal lines, I see that all horizontal lines will cross the graph except at 2, which tells me that the range of this function is negative infinity 2 union to infinity. Acceptable so far? Okay. So then this answers part 1. Now for x and y intercepts, I see an intercept here, and I see an intercept here. So obviously this is the x-axis. So this point will be 2, 0, which is the x-intercept. And this point will be 0, 4, which is the y-intercept. Y-intercept, x-intercept. Are we in agreement with that? Yes? Okay. So I answered the second part. Find f of 4. What is given in this question? The x is given. So you can draw, or at least imagine that you draw, a vertical line which is x equals 4. You see it crosses the graph of the function somewhere, and you will have to try to identify this. It's hard. I have to agree. So I will accept any approximation, or of course you cannot say it's 10, right? Then I will not accept. But if you say somewhere between 0 and 2, and you try to, divvy up into, I would say, roughly 175 myself. So I will say 1.75 when x is 4. So this is what I would present for number 3. Now find the value or values of x when f of x is negative 2. What is given now in this question?
The y.
The y. So now I have to draw, or imagine I draw, a horizontal line which is y equals negative 2, and I see it crosses the graph of the function in this point. And again, this is not easy to read. I just wanted to see what you're going to come up with. So I would say roughly the same thing, like 1.75 comma negative 2 will be the answer for number 4. This is a very important type of problem. We have to be able to read, even if we have to approximate, just to have an idea from a graph. It's very important. Okay, very good. Any questions for me? So now let's go to your questions. Anything that you worked on, anything that you had difficulties with, anything that you would like to see, anything. anything from the material for test 1? Is there anything that you would like to go back to? Yes, Becky, you have something for me? Okay, very good. Okay, if not, if you don't have anything for me, then I will go back to chapter 3, and then chapter 4, and then chapter 8, and then chapter 9, and review again. Okay? Ready? Okay. So this I don't need. Good. And today I think is the 19th. Okay. Good. So on page 244 and page 245, let's go back and let's say problem 123, but I don't like the requirement of presenting the equation in the ax plus by equals c form. That's not a useful form. So we're going to use two ordered pairs, and we are going to be asked, or we will have to determine the equation of the line passing through them. Okay, 1 minute. I want participation. I want you to work on this and show me the answer. So we are given 2 points. We're asked to find the equation of the line passing through them. I'm going to write a couple of problems, and then we'll go. Don't copy anything else yet. Yes, Becky? So this is 65 on 4, that one. 63 and 65 and 4, that one. Okay, good. So let's work on these, and then I will not forget. 63 and 65 and 4, that one. We are working on this.
Just to find
The equation of the line passing through the given points. Yes. Do we need more time?
page number.
244, 245. Do we need more time? Okay, so give me some answers. I'm going to write them here.
Y equals negative 4x minus 3.
Okay, another answer? I don't have the answer. I'm just copying down whatever you tell me. Is this the only answer? That must be the right one then. Okay, very good. So just for everyone to see this, so we have to find the slope. y2 minus y1 over x2 minus x1, and I will write 5 minus 9 over negative 2 plus 3. So this is negative 4 over 1, which is negative 4, exactly the slope that you got. And then I will write y minus y1 equals the slope times x minus x1, where I'm going to use this point. It doesn't matter really which one you use, with a slope of negative 4. So then I have y minus 9 equals negative 4x plus 3, negative 4x, and I have negative 12 plus 9 is indeed minus 3. Yes, negative 12 plus 9. Indeed. Perfect. Okay. So our next question is problem 100, and we want to find the domain of this function. 1 minute. Good, well done. If you did not get that, or you did not know how to, I hope you will by Thursday. Do we have an answer already for the domain of function g? Anyone can give us an answer? Anything?
Union.
Very good. This is indeed a domain. It's a rational function. Therefore, x minus 2 cannot equal 0. We add 2 to both sides, which means x cannot equal 2. This is signified by this interval notation. Very good. The same question, I just made this up. It's not in your book. Same question for this function. F of x equals 2x plus 4. And here I will also like to graph it. Graph this function. So we have f of x equals the square root of 2x plus 4. And we want to graph this function as well after we find its domain. Okay, this requires 2 minutes. Maggie, you want to say something? Matt, you had a question? Do we need more time? Do we have an answer for the domain? We do or we don't? Very good. So the reason is, remember, when we have a square root function, this quantity, whatever I have under the square root, must be greater than or equal to 0. Now, if this quantity is in the denominator, it cannot be greater than or equal to, but it's not in the denominator. So I have to state the restriction. Please try not to forget this. I mean, for some reason, I'm not sure why, my students don't like square roots. And always forget to state this restriction. Move forward, divide by 2, so 2x greater or equal to negative 4, x greater or equal to negative 2, which indeed means this. And now I would like to see the chart of values of x and the corresponding ordered pairs. So you have to present this starting with -2 and going to infinity. You have to start by picking -2 and plugging it in. It's a must. And then let's find two other values of x, so that when I plug them in the function, it's very easy to take the square root from. And you can say, well, we didn't get to square root. I have to agree. This is entirely chapter 10. Everything in chapter 10 is about this function. But we have to have the basics. Okay? So give me two more values and the corresponding y values. Two more x values and then the corresponding y values.
0.
Very good. 0 is a good one. Why? Because 2 times 0 is 0. The square root of 4, 2. And I need, which one? Very good. Excellent. Because 2 times 2 is 4 and 4 plus, oh, that 2 doesn't work. Sorry. So 2 times 2 will be 4. 4 plus 4 is 8. It works. It works, but it will be an approximation. You can. Since I put it in there, we'll use it. That's okay. But I wanted something that I can easily take the square root from. And when we plug in -2, 2. Because we have, hold on. -2 times 2 is -4. -4 plus 4 is 0. So I would prefer having here the square root of 16, which is 4. What should I have as x if I want 2x plus 4 to be 16?
6.
Yes. So let's do that. Or you just take the square root with a calculator and approximate it. Good. These are very important functions. So far we know 3. We know the linear function, we know the square root, and we know one more. What was the third one that we discussed?
Absolute value.
Thank you. Good. So the first ordered pair from left to right. Very good, right here. 0, 2. And 1, 2, 3, 4, 5, 6, 1, 2. And I know the graph is not a line. So this is the square root of 2x plus 4. Yes, I will ask you also to identify the range. What will be the range of this function? Range, please. Correct. Very good. Perfect. Okay. Now I would like to graph this equation using x and y intercepts. So let's graph this equation using x and y intercepts. Some students will go ahead and solve this equation for y. There is no need. Can you do it? Yes. Will it be wrong? No. Will you get full credit? Yes. Don't waste your time, though. How do I find the x-intercept?
Set y to 0.
Excellent. Here's what I do. Look at this for a second. Y 0. How much is x? What is the ordered pair that we just determined?
3, 0.
Very good. How do I determine the y-intercept?
Set x.
How much is y? What is the ordered pair that I just determined?
0, 2.
Very good. Excellent. That's all I need. And it's done. So I plot 3, 0 and 0, 2. Connect the line, extend, put arrows, write the name, which is 2x plus 3y equals 6, x, the origin, and the y. And this is it. Okay. I would like you to think about the following problem. 53 on page 243. We're given two lines, two equations. X minus y equals -6 and x plus y equals 3. Determine whether they are parallel, perpendicular, or none of the above. Determine whether they are parallel, perpendicular, or none of the above. You do not need to graph. Let's think for a minute. This is a totally different problem. Don't copy anything. So just think about the first one. Can anyone identify or tell us anything about these two lines? How do I know they are perpendicular and what do I have to do? I have to solve for y to find the slope. Very good. So -y equals -x minus 6. I will multiply or divide by -1. And I get that y equals x plus 6. What is the slope of the first line then? Very good. I repeat the same steps for the second one. I solve for y. I get y equals -x plus 3. What is the slope of the second line? Is their product -1? If their product is -1, they must be perpendicular. Yes. m1 times m2 equals -1. Therefore, lines are perpendicular. Okay, I'm given this graph, and I'm asked to identify the slope of this line. And I am told that this line passes through these points. -2, -2, 3, -1. Yes, I can plug them in the formula in y2 minus y1 over x2 minus x1. Easier than that. First of all, does this have a positive slope or a negative slope? Positive slope. What is the difference in the y values? From -2 to -1, so this is 1. What is the difference in the x values? How many units do I have between their x values? 5. What will be the slope of this line then? Rise over 1. Rise over 1 and positive. Is this clear? Yes? Okay. I really don't know what else I could review for chapter 3. It's basically it. Okay, let's look at chapter 4. In chapter 4, I would like to start with those two problems. On page 257, before we look at the review. Page 257, problems 63 and 65. Okay, so let's read 63. Draw a graph of two linear equations whose associated system has the solution -1, 4. It says draw. It doesn't say determine the lines or determine the equations. It just says draw. And the solution has to be -1, 4. Okay, so here is my take on it. -1, 4 is definitely here. And now I'm going to draw two lines that have the solution as a system. This is my first line. I'm going to say line 1. And this is my second one. I'm going to say line 2. And that's it. That's all I had to do. In 65, draw a graph of two linear equations whose associated system has no solutions. How will I graph a system of two lines, in other words, of two equations that has no solutions? Right, it's up to you. Doesn't matter. You decide how you want them to look. As long as they never meet. Good. Becky, is this okay? These were your problems. Is it okay? Perfect. So now let's review chapter 4 review. It starts on page 301. Okay. Let's look at a couple of systems. Let's say problem 20. On page 302. So -3x plus y equals 6, and y equals 3x plus 2. We want to solve this system. And then I'm going to copy two more problems. Here's another one. Don't copy more. Just work on this one, and then we'll copy it together. 4y equals 2x. I'm not indicating the method. It's up to you. And then I would like to look at some more problems. Doing more time on number 20. Are you ready? Okay, so can anyone tell us what to do first? Or which method? Yes, Becky? That's fine too, yes. So you want to replace this by this. Perfect. So we have negative 3x plus 3x plus 2 equals 6. It turns out that 2 equals 6. What do we conclude? Yes, no solutions, which means the lines must be parallel. I want to convince myself that I didn't make a mistake. How do I convince myself in this case that I did not make a mistake? That's possible, but even easier than that, find their slopes. What should their slopes be? The same number, whatever it is, but the same number, right? Okay, so it is true, since the slope of the second line is 3, and we solve the first equation for y, I get 3x plus 6. Obviously, both slopes are 3, and I know that I did not make a mistake. I was correct that the system has no solutions. Inconsistent. Inconsistent system. In other words, no solutions. Perfect. Let's work on 17. 4y equals 2x plus 6 is the first equation. And x minus 2y equals negative 3. Yes. $53, 4.3. Yes, of course. I copied it one more time because I don't have room here. Are we ready for this one? Okay, any suggestions? And then I'll tell you what I would like to do.
I just found this slope.
Okay, so you decided to find the slopes and see if there is a solution or not. Okay. However, that is not the best idea. Let me explain why. I may have, so let's say the slopes are equal. What will you conclude?
That the slopes are equal. That they're the same. I mean, that is this. Oh.
You got it.
Is it? Oh, that's why. Okay.
So here I went in the reversed way. Here's what I did. I found no solutions as the answer. And then I said, let me check that the slopes are the same. But I cannot, by simply checking the slopes, conclude, because these two lines have the same slope. But the system has infinitely many solutions. So that is just like a check when you find no solutions for a system. But you cannot just look at the slope and say, oh, I'm sure they never meet, because they may be the same. Clear? Well done. I love it when I don't have to explain, because I saw the light coming on. Okay, good. So here's what I would like to do. I would like to move 2x to the other side. So negative 2x plus 4y equals 6. And then x minus 2y equals negative 3. And you have two options here. You either multiply this by 2 or divide this by 2. It doesn't really matter. So let's say we multiply the second one by 2. Then we have negative 2x plus 4y equals 6. And 2x minus 4y equals negative 6. Which I know it means what? Say it again. Yes. So infinitely many solutions. Infinitely many solutions. However, I think I showed you, and I would like to show you again, the elegant way of writing. I accept this. But the elegant mathematical way of writing the solutions in this case is this. We solve for one of the variables. I can't solve for both because they're both the same equation. I can only solve for one. So I will solve for this, and I will say x equals 2y minus 3. I don't know why I wrote plus. I don't know what went through my mind and made me write plus. I meant to copy that. Okay, so this is our x. For any y value. So I solve for x. X is 2y minus 3, and y is y. So this representation or this representation mean the same thing. However, this is more elegant and better. Why? Because I can give you ordered pairs. Here, I cannot give you ordered pairs. I can only say there are infinitely many. But here I can even specifically give you ordered pairs. If y is 0, x is negative 3. If y is 1, x is negative 1, right? 1, 2, minus 3, negative 1. If y is 3, then I have 6 minus 3. This is 3. So 3, 3 will be another ordered pair. If y is negative 1, then this will be negative 5. So I have negative 5 comma negative 1. So that's why this is a better notation, because I can give you ordered pairs. I pick any y, I have to calculate x. So if y is 0, then x is negative 3. If y is 1, then x is negative 1. If y is such and such. So that we prefer that. Okay, one more system, 56. Negative x minus 15y equals 44. And 2x plus 3y equals 20. And then we'll look at 53. On page, yes, Becky? Yes. Oh, I'm sorry. So you said in 4.3, problem 53. Of course. 53. Yes, I see it. I'll copy it. So we're looking at 56. Negative x minus 15y equals 44. And then I'm copying 53. Over and x over 2. So we're working on 56, which is negative x minus 15y equals 44, and 2x plus 3y equals 20. And let me know what you get. And then I would like to review some word problems, motion, mixture problems, the riverboat, type of problem, and so on and so forth. Okay, ready? Any suggestions here? Very good, excellent. So negative 2x, negative 30y equals 88, and 2x plus 3y equals 20. Obviously, we're trying to eliminate x. Is this okay? Okay, so then I see here a negative 27y. Is that correct? And I see here 108. Right? So negative 30 plus 3, negative 27, 88 plus 20, 108. So then y equals negative 108 divided by 27. Good. So it appears that is negative 4. And now I don't care where you go back. Doesn't matter. And you have 2x minus 12. 2x minus 12 equals 20. I have to move 12 to the other side, and I get 32. And I divide 32 by 2, and it appears that x is, so 2x equals 32, x equals 16. The solution appears to be 16 comma negative 4. I have no idea whether it's true or false, but I will check it out. So 16 and negative 4. Both equations have to work, otherwise this means nothing. So negative 16 and plus 60, right? Negative 16 plus 60 is 44. And then 32 minus 12 is indeed 20. And this is a yes. The system is consistent and the equations are independent. Any questions? Okay, now we have a problem from Becky. She says we have to do this problem now. 53. It comes from 4.3. I forgot to write the page number. I'm going back there. 4.3. 4.3 is 271. So let's work on this system.